going to further discuss equations of motion. Today, specifically, we'll be talking about multi-stage problems. So we're still on equations of motions and we're discussing multi-stage problems today. Okay, here's the first question from the book. It's very blurry. I will read it out to you. A cyclist is freewheeling down a long straight hill. Have we done this before? I have a feeling we've done this before. Just give me a second. No, we haven't. Okay. A cyclist is freewheeling down a long straight hill. The times between passing two successive kilometers posts are 100 seconds and 80 seconds. Assuming the acceleration is constant, find this acceleration. Okay. So a cyclist is freewheeling down a long straight hill. The times between passing successive kilometer posts are 100 seconds and 80 seconds. So first, let's say he starts from here and there's a post here at 100 meter, at 1,000 meters, because it says kilometer post. So that means this would be 1,000 meters. And the other post would also be a kilometer long. So that means 1,000 meters. Because SI units for distance is meters. So that's why we're converting it into meters. Okay. And he passes the first post in 100 seconds. So the time here is 100 seconds. This is S, the distance. This is S, the distance. And the time in which he passes this 1,000 meters distance is 80 seconds. Okay, so there are two stages in this question. Hence, it's called a multi-stage problem. Assuming acceleration is constant, so the acceleration in both the stages is the same, find this acceleration. Okay. So what you do in this question, these kind of questions is you consider this movement from here to here, and then you consider this entire movement from here to here. So instead of breaking it into two journeys of 100 meters and 100 meters each, we're going to break it into two journeys, but we'll say one of them is 100 meters, 1,000 meters, not 100 meters. So one of them is 1,000 meters and the other one would be 2,000 meters. Now, why are we doing this? Why are we taking the first journey of 1,000 meters and the second journey of 2,000 meters is because for both these journeys, the pink journey and the green journey, the initial speed is going to stay the same. So it's going to be u for both the journeys. The initial speed is going to be u for the pink journey and the green journey. So that will help us in solving the equations because both the equations will have the same value of u. Okay, so now let's look at the first equation. There's a u that we have to incorporate in the equation. There's a t, which is 100 seconds. There's a distance, which is 1,000 meters. And also we need to talk about A in this equation because we need to find A eventually. So for the first part of the journey, let's say this is A, this is point B, and this is point C. So we're talking about from A to B. So which equation of motion should we use that has U, T, S, and A? I'm going to write all the equations of motion over here. V is equals to U plus AT. V square equals U square plus 2AS. S is equals to UT plus half AT square. S equals VT minus half AT square. And lastly, S is equals to half U plus V times T. One of the equations I've written in red because that one is not there in the formula sheet. The others are mentioned. So that's why I've mentioned it in red. Yes, so which equation do we use that has U, T, S, and A in it? This one. S equals UT plus half AT square. Can you guys hear me properly?
Yes, ma'am.
Okay. So S equals UT plus half AT square. So S is 1000 meters equals U is U, T is 100 plus half, A is A, and T square is going to be 100 square. Simplified, we get 1000 equals 100 U plus 100 square divided by 2. This should be 5000 plus 5000. A. Now I'm going to further simplify it. I'm going to divide it with 100. So it's 10 equals U plus 50A. Calling this equation number 1. From the first stage, A to B. Now I'm going to do the same for the stage B, A to C. I've chosen A to C so that the initial speed stays the same. So now there's a U, there's a T, which is going to be 180 seconds. Because for the total journey, the time would be 180 seconds. There's S, which is 2000. And of course, we need A in the equation as well because the question is asking for the value of A. So now again, we're going to use the same formula that has S, U, T, and A in it. So S is equals to UT plus half AT square. 2000 equals 180U plus half A T square is going to be 180 squared. So we get 2000 equals 180U plus 180 squared divided by 2. 16200. Okay. Now we can divide both sides with, let me check.
मैम साथ ए नहीं लगेगा?
हाँ लगेगा बिल्कुल. Okay, we can divide both sides with 20. Divide by 20. So we have 100 equals 9U plus 8100A. Just a second, 180 square divided by 2 is divided by 20. It should be 810, not 8100. Okay, this is going to be the equation number 2. Now you can solve these equations simultaneously and get both u and t. The question is only asking for a, so you don't really need to find u. There are no marks for finding u. So what you can do is eliminate u and find a. So you can use substitution or elimination. I'm going to use elimination. So I'll have to multiply the first equation with 9. So that gives me 90. In fact, let's use minus 9. So minus 90 equals minus 9u minus 450. Okay. And then the second equation is 100 equals 9u. Okay, this was a, sorry, minus 450a. And this is plus 810a. Okay. 9u and 9u gets eliminated. We have 10 here. And what is 810 minus 450? It's 360a.
Three.
So a comes out to be 1 upon 36 meters per second square. You can leave it as a fraction or you may write it as a decimal correct to 3 significant figures. So that is how you solve a multi-stage problem. You will be forming simultaneous equations for both the stages. So you have to take the first stage and combination of first and second stage to make sure that you can use the same u in both the equations. अगर कोई क्वेश्चन है तो प्लीज पूछो इधर. If not, then I'm going to copy the next question. Okay. Question 9. A train is slowing down with constant deceleration. It passes a signal A, and after successive intervals of 40 seconds, it passes points B and C, which are 1800 meters and 1400 meters. Let me draw this. So there's a point A to B, 1800 meters. And then there's a point B to C, distance B to C, which is 1400 meters. So we have A, B, and C. Okay. A train is slowing down with a constant deceleration. Since it's constant, we can use equations of motion. It passes a signal at A and after successive interval of 40 seconds. That means time here would be 40 seconds and time here would be 40 seconds. Where AB is 1800, BC is 1400. How fast is the train moving when it passes through A? That means we have to find U. So the initial speed here is U. So you're going to take this journey, which has an initial speed of U, and you're going to take the entire journey. That also has an initial speed of U. You're not going to take the journey BC because for BC, the initial speed is not U. Speed here is not U, it will change. It will be the V of the first stage. So that's why we won't be complicating it and instead just sticking to the first part of the journey and the complete journey. Okay. So again, we need to find T. No, how fast. So we need to find U. Okay. Also, we know that the deceleration is constant. So A is constant in both the journeys, the green journey and the yellow journey. Okay, so let's start solving it for AB. We're going to use the same equation. S equals ut plus half at square. S is 1800 equals u 40 plus half a 40 square. 1800 equals 40u plus 800a. Divide both sides with 40 work. Yes. Divide both sides with 40. So 45 equals u plus 20a. Equation 1. Okay. Now consider the journey from A to C. From AC, or yeah. So now same formula, S equals ut plus half at square. S is going to be 1800 plus 1400. 3200 equals U is what we have to find. T for the entire journey is 80 seconds plus half A 80 square. So 3200 equals 80U plus 80 square is going to be 6400 divided by 2, 3200. A, divide both sides with 80. So this would be 40 equals U plus 48. Equation 2. Okay, now solve these two equations simultaneously using substitution or elimination. We need to find
I have a question.
G.
क्या आपने इक्वेशन 1 और इक्वेशन 2 दोनों को उनके सेकंड लास्ट स्टेप में डिवाइडेड बाय 40 डिवाइड बाय 80 खुद ही किया, लाइक इनको फैक्टराइज
Yeah,
करने
just
के
to
लिए?
simplify. No, just to simplify it. Because we will be
So
solving them
miss, my
simultaneously. Hmm.
my question is कि how did you know कि 40 is the highest divisible factor in तीनों का, या 80? I know it's a very basic question, but I was
Hey,
confused
it
about
was
that.
honestly, it was hit and trial. It was hit and trial. You can first divide both sides with 2, and then you'll see that it's again divisible by 2. So you will do it again. And then you'll see it's again divisible by 10. So you can do it again. So you can do it in many steps till there's no value that
Okay.
you can divide on both sides. Okay. Plus, we have a calculator, so you can quickly check because the smallest value here was 40. So I checked if everything divides with 40, so it did. And here the smallest value is 80, so it did divide with everything. But that is not always the case.
ठीक है, thank
Okay,
you.
now let's solve this simultaneously. So we multiply, I'm going to multiply this with -1 so that it becomes minus u. Okay, no, in fact, we needed the initial speed. How fast is the train moving when it was passing through A? So I'm going to try and eliminate A. So for that, I have to multiply the first equation with -2. So multiply this with -2. So we get
मैम यू
hmm? आंसर बता रहे हो?
U50 बनता है और जी
U50
और ए जो है -0.25।
-0.25. Okay, let's check. I will not be finding A because the question is not asking for it. But if you did, that's fine. Okay, minus 90 is equals to minus 2u minus 40a. Second equation is 40 equals u plus 40a. So a gets eliminated. We have minus 50 equals minus u. I'm getting u equals 50. Why are we getting different answers?
No, मैम 50 था यू
50 था? Okay, ठीक है, 50. Okay, so u is 50 meters per second. In this particular question, they've only asked for u. So I'm not going to find a. Okay. Part B is how far from A does it come to a stop? Okay. So at what distance does this cyclist, or sorry, the train stops? Okay, so it definitely stops somewhere after C, because we know it's not stopping before C because you're given data till C. So it starts from A, goes beyond C, and stops somewhere over here. Let's call it a point D. So it starts from A. We know that at A, U is 50. You have to find the distance from A to D where it stops. So S is question mark. We don't know the time. From A to D, it hasn't been mentioned in the question. We don't know the acceleration. In fact, we do know the acceleration from the previous part, since it said that the deceleration is constant throughout this question. So now we'll have to go back to the previous part and find deceleration because we'll need it in the next part. Okay, so once you have u, you can put it back in any one of the original equations. I'm going to use the first one and get a. So 45 minus 50 is going to be minus 5 equals 20a. So a is going to be minus 1 by 4 meters per second square. Okay. So I'm going to use that here. Now for the entire journey, deceleration is going to stay the same. Okay. And it is asking for the distance at which it stops. So that means the V over here would be 0. So V is 0. Okay. So now we need an equation of motion that uses U, S, A, and V, which I believe is going to be V square equals U square plus 2AS. So 0 square equals 50 square plus 2 minus 1 by 4a, and s is what you have to find. Okay. So it's going to be 0 equals 2500 minus half s. Half s equals 2500. S equals 5000 meters. कोई क्वेश्चन है तो प्लीज पूछो. Okay. चलिए. Next part is, so we're done with equations of motion exclusively. So the questions we've done in the last couple of days only had the topic equation of motion in it.